With this presentation, I hope to help you better understand the basics of a hydronic system and how you are able to control the warm or cool air you are receiving in a commercial building. The objective of any building heating or cooling system is to provide the maximum level of human comfort. To achieve this, we are just delivering hot or cold heat transfer fluid through a series of pipes, which can heat or chill the air at the terminal unit, which is just behind that vent on the wall. The particular system being covered today is a 4-pipe piping system. Comfort is achieved by controlling the rate and manner in which heat is transferred from the body. Modern-day hydronic systems are comprised of 3 main parts. They are the heating and cooling sources, the distribution system, and the terminal units. This particular system uses a boiler to heat the water and a cooling tower to chill the water. The most commonly used heat source in hydronic systems is the boiler, which has many forms. This particular boiler produces steam that runs through a heat exchanger that heats the water. The most frequent cause of non-performance in a heat exchanger is improper venting and fouling. A cooling tower is a device used to reject heat from the water circulating through a building's water loop system or chiller condenser. The 3 things needed on the suction side of a pump are a pressure-reducing valve, expansion tank, and a manual air vent. After the water has been heated or chilled, it is then pumped through an air management system and then a series of pipes to distribute it into the building to be used at the terminal units in their desired locations. Steel pipe is normally used for larger sized hydronic heating and cooling piping in commercial and industrial installations. As you can see, there are markings laid out by the manufacturer to show that it is made in accordance with American Society of Testing Materials A53. A hydronic piping system is not only comprised of pipe and fittings, but also has other important components and accessories as well. The components shown are located on the secondary loop of this building's hydronic system. Temperature and pressure gauges are installed to easily monitor the operating condition of the system. The Y strainer is installed to catch any particles or debris in the heat transfer fluid from re-entering the system. A pressure relief valve is an automatic pressure relieving device actuated by the static pressure upstream of the valve, and it opens further with the increase in pressure over the opening pressure. There are 2 types of air handler units, draw-through or blow-through. This unit is a draw-through air handler, which means the coils are on the suction side of the fan. An air handler unit, or AHU, usually has an air filter, first set and second set of coils, and a fan. Other items, such as dampeners and humidifiers, may be added. The first set of coils gets the heated HTF, and the second set of coils gets the chilled HTF. This is to ensure that on a hot or cold day, the supplied air will remain at the same temperature. Once the air has gone through the air handler, it is then delivered to the heating coils in their specific zone. Zoning allows for the independent control of separate building spaces, which will, in turn, help to reduce energy costs by using only the energy to heat or cool a zone when and where it is needed. This system uses a 2-pipe reverse return piping system, where the first terminal unit taken off the supply main is the first to connect to the return main. This is the tertiary loop in this building's hydronic system. A hydronic heating coil usually has 1 or 2 rows of copper or aluminum coils that the heat transfer fluid is pumped through, and the air from the air handler is blown across. This allows you to turn on or off the heated HTF that is being pumped through the coils, in turn letting you adjust the temperature of the air being blown out of the vent in the room or that specific zone. I hope that this presentation has helped you better understand how many of the heating and cooling systems we operate or are surrounded by every day keep you comfortable.